In this section, we will discuss the classification and mechanism of action of immunosuppressants. Keeping the points of previous section in mind, let's classify the immunosuppressants. As we said that we can decrease T-cell activation. So we can decrease T-cell activation by 3 ways. Inhibit activation of nuclear factor of activated T-cells, which is interleukin-2 transcription factor that will be discussed later in this video, through Cyclosporin and Tacrolimus. We can inhibit co-stimulatory signals, as we have discussed that, along with TCR, and MHC binding. We also need other receptors, or co-stimulatory signals, for T-cell activation, such as binding of CD28 on T-cell, and B7 receptor on dendritic cells. This co-stimulatory signal can be inhibited through belatacept, which is CTLA-4FC fusion protein. Third, we can inhibit interleukin-2 receptor signaling through basilizumab and daclizumab. Both are interleukin-2 receptor monoclonal antibodies, and through sirolimus and everolimus. Both are mTOR inhibitors. Secondly, we can suppress immune system by T-cell depletion through anti-CD3 antibody, for example, muromonab CD3, or through anti-thymocyte globulin, for example, thymoglobulin. Thirdly, we can suppress immune system through other agents, such as glucocorticoids, for example, prednisone, and antimetabolites, for example, azathioprine. Still confused? Okay, let's understand their mechanism, that how these agents suppress function and processes of T-cell to suppress immune system. This is dendritic cell. This is T-cell. Peptide MHC complex binds with alpha-beta T-cell receptor and CD3 complex. B7 receptor of dendritic cell binds with CD28 receptor of T-cell. This is CD52 receptor of T-cell. This is interleukin-2 receptor of T-cell. Now, when CD3 activates, it causes increased calcium influx and combines with comodulin and activates calcineurin, which is a phosphatase. As name of enzyme indicates that it removes or cut off phosphate from nuclear factor of activated T-cells. So phosphate is removed from the nuclear factor of activated T-cells, and it is now dephosphorylated. It then moves into the nucleus and causes interleukin-2 transcription that leads to production of interleukin-2. This interleukin-2 binds the interleukin-2 receptor that causes upregulation of mTOR that are responsible for production of cyclins. Function of cyclins and CDKs is their control of cell cycle progression. Cyclin CDK complexes appear to be the master regulators of the cell cycle, controlling the events and timing that define each phase. Immunosuppressive drugs act at different stages in the activation of alloreactive T-cells. Rapid anti-thymoglobulin and anti-CD52 monoclonal antibody, for example, Alemtuzumab, are used to deplete T-cells and other leukocytes before transplantation. Anti-CD3 monoclonal antibody prevents the generation of signaling by the T-cell receptor complex, for example, muromonab CD3. Whereas Cyclosporin and Tacrolimus interfere with the translocation of nuclear factor of activated T-cells, or NFAT, to the nucleus by inhibiting calcineurin. Cyclosporine is firmly established as a first-line therapy in the prophylaxis and treatment of transplant rejection. Another T-cell-specific immunosuppressive drug, tacrolimus, contains a macrolide ring structure, and although originally also found in a fungus, is isolated from the bacterium Streptomyces sqadia. Like cyclosporine, tacrolimus is a calcineurin inhibitor that blocks various T-cell and dendritic cell activities. But again, like cyclosporine, it has the drawback that it is nephrotoxic at high doses. Regarding the molecular details of the mode of action of these drugs, cyclosporine complexes with cyclophilin A, which is a member of the immunophilin family, whereas tacrolimus complexes with another immunophilin family member, FK binding protein. These complexes then interact with and inhibit the calcium and comedulin-dependent phosphatase calcineurin, which activates the NFAT, or nuclear factor of activated T cells, which is transcription factor for interleukin-2 inactivated T cells. The CTLA-4FC fusion protein, belatacept, binds B7 and prevents the generation of co-stimulation through CD28. Basilizumab, which is an anti-CD25 antibody, binds to the high-affinity interleukin-2 receptor on partially activated T cells and prevents interleukin-2 signaling. Sirolimus and everolimus interferes with activation of the mTOR cascade, which is required for differentiation of effector T cells. Rapamycin is a drug that can be given orally and interacts with signaling events downstream of the interleukin-2 receptor. Rapamycin is less potent and easier to take than the monoclonal antibodies, so it is used to prevent graft rejection. The rapamycins, such as sirolimus and everolimus, are also macrolides. But in contrast to tacrolimus, they block mTOR signals induced by combination of interleukin-2 with its receptor. Sirolimus is a product of Streptomyces hygroscopicus, whereas everolimus is a 2-hydroxyethyl substituted derivative of sirolimus. Azathioprine and mycophenolate inhibit the replication and proliferation of activated T cells. Mycophenolate mofdil and mycophenolate sodium, which when metabolized to mycophenolic acid, inhibit the inosine monophosphate dehydrogenase enzyme required for lymphocyte proliferation. Corticosteroids, such as glucocorticoids, inhibit synthesis of more than 100 proteins, but at low doses, they predominantly act on antigen-presenting cells, preventing some of the early stages of graft rejection. Higher doses of corticosteroids have direct effects on T cells and are used to treat episodes of rejection. This was all about immunosuppressants. Stay tuned to sqadia.com for more precise and knowledge-stuffed videos.